Alright, let's see where we're at. Day 2, yeah, day 2's pretty much good enough. Day 3, let's move on to day 3. Let's change this to 2. That is day 3. Yeah. Alright. What was day 3? Hello, chatter. Identification. One elf has the job of loading the rucksacks. Okay, so this represents the contents, and you can split that in 2. And what are we doing? Lowercase, get these priorities, uppercase, get those priorities. The priority of the item type that appears in both compartments of each rucksack is 16. 42, 22, 20, 19. The sum is 157. Okay, well, first of all, let's put some asserts in there. Day 3. And it's just that, right? So this is the first solution. That is the first solution. And that is the second. Yeah, except yeah, it's just an int 2. Well, it's sum, I guess, yeah, we can just call it sum part 1 and sum part 2. Well, I mean, I guess it's, you can just give them those names. Shared item priority sum, and then badge priority sum. And just remove that. Remove that. Yeah. So this would be shared item priority sum, and this would be badge priority sum. Yeah. Yeah, it works. Alright, well, given that we have this shared item and badges, what can we draw based on this? Well, let's look at part 1. Contains these items, yeah. The first compartment is the first half, the second compartment is the second half. The only item that appears in both compartments is lowercase p. Yeah. Well, I mean, I guess we can print this string, like this half, and then just highlight whatever common element they have. Probably this one on top, the second half at the bottom, and just highlight the common element. Well, I mean, we could do that. But there's also these priorities. And highlighting common elements isn't going to give us a sense of what those common priorities are. And I mean, again, it's a sum. It's like each of these just boils down to a number, and you just keep adding that number. I mean, I don't want to do another rectangle series, because we kind of saw that in part 2. I'm gonna do something else. But I mean, if you're gonna read the result, that's just a sum of things, then what else are you gonna do other than a series of rectangles? Well, I mean, at least in part 2, we had a color coding of outcomes. So we had something other than a rectangle series. Whereas here, well, I mean, if we do draw the two strings and highlight the common element, that will take a certain amount of space just on its own, and that space isn't necessarily going to be proportional to this priority. I mean, some of them have priority 1. Lowercase a has priority 1. And if you have a compartment like that, a backpack like that, and A is the element, then well, you can't really make it like small. Like, we could, of course, just take the common element, pull it out, and draw that inside of a rectangle, but oh my god, this the micro UI has gotta go. Like, if each of these had a little letter inside of it, that would be kind of what we were looking for. But it's so similar to part 2. I mean, I guess that's just the nature of Advent of Code. It all comes down to some series of numbers that you're adding up, or sorting, or whatever. I mean, we could just do that again, but with letters in here, and then without the legend. I guess, I don't know, it could give you the ability to hover over something and like see the string. That would be something extra, but otherwise it's actually the same. Yeah, let's do that. Let's do the first part of that, which is well, getting the data. So for each of the backpacks, we want the two compartments. Abstract backpack. We want the two compartments. And we want the common element. So that's part 1. And we just have a series of these. Backpack, backpacks. Are we using the arena for anything? No. That means we can just put it on the arena. Dynamic array of backpacks. Backpack storage is, well, I mean, we just want to call that and give it this arena and give it an arena free size. That, yeah. then at the end of this loop, just construct one of these backpacks. Do I have the two comp1, comp2? And do I have a shared? Let's see, there's the two compartments. Comp1 item, comp2 item. Okay, so looks like I'm getting the priorities for the items. And then storing them in there. Okay, so I'm not really keeping the priority. I mean, we can always just store the priority and transform it, like back transform it from here. Well, yeah. Let's just do that. Int shared priority is 0. Okay, so shared priority is that, and yeah. So now we have this shared priority, and I mean, we do kind of want this. I mean, we want both probably. Int common priority, because that's what we are summing, right? We're summing priorities, but we also want this for the purposes of drawing. Now, common. So we need the character. So we need this back transformed character, and then common priority or shared. Yeah, shared common whatever. Shared is okay. So what's the transformation? Well, if it's less than or equal to 26, if it's less than or equal to 26, then it's just that number. Actually, we have ternary, right? Plus A, otherwise it's shared priority plus A. What's that? Yeah, and now we just do backpack storage, push, backpack. Yeah, and at the end of the function, we do backpacks is backpack storage buffer 0 to backpack storage length, and then arena used equals used before plus the size of that, so like backpacks length times backpack size. So use before, so just before this we do long used before let's just wrap it, right? And then do a cast char here. .43 is lowercase. Is that lowercase l? Is that some other? I mean, that looks like lowercase l. Okay. Oh, it's not shared priority plus A. That's right. It's actually, let's look at it again. Priority is 1 through 26. So if it's 1, then it's actually -1 here. Right? Like, this is the offset from A. And this is 27. So A, capital A, has priority 27. So if the priority is 27, then we minus 27. Yeah, that looks about right. Shared priority 43 is Q, which looks about right, yeah. TPWJ 10 PRG SE. Yeah, I mean, we could just look at Q, look at the inputs and see what's up there. Okay, so Q, yeah, looks about right, Q. And then T, yeah, there's T, yeah. Also can confirm it through just looking at the backpack. Comp 1, comp 2, yeah, there's T and there's T. I mean, that T, really. Anyway, this seems like it's working. J, yeah. What are we taking? Used before here, used before plus length times size of the backpack. Okay, so this looks about right. I mean, we are using this pattern a fair amount. Maybe we should start it in some other way. Yeah, because we're essentially doing that here, and doing that here, doing that in the first one, I think, as well, here. reconstruct it, give it the arena, and just... Well, here's an idea, right? What if we just take it? What if we just give it an arena? And then have the dynamic array do the rest of the work for us. So if you don't give it, then we'll just do arena free size. Arena used before. Actually, both of them can do that, right? Like this thing can do this arena free size. Yeah, we can just keep track of it here in the array itself. Push, copy, and then I don't even really... to slice, maybe? Something like that. Well... It's something like we want to convert it to slice, but also keep it on the arena is the only thing that's on it, right? It's like keep... anyway, let's just do to slice for now, whatever. To slice. What does this do? It does... Oh, so that means we kind of do want to keep the arena pointer around. Arena used before, and then t result is buffer 0 to length. Return result. Use before plus length times t size of. So we don't need that. And then calorie storage could just be calorie storage dynamic to slice, and that we don't need, I think, essentially. Yeah, we have to keep the arena pointer around. constructors, it's arena underscore. Well, here it's fine. Here it has to be that. Here it has to be different name. Copy. Yeah, that seems about right. Okay, so that's that. That we don't need. Here we can just pass this. Rounds part 1 storage. Okay, so we don't need to do this manually. To slice. That we don't need. Just pass it that. And then just do backpack storage to slice. That. Well, doing it this way, right? Okay, so there's our stuff. There's the arena. Use 1024, which is all of it. But then we want to do, oh my god, to slice. Now use this 40, which is about right. Which is why we can actually copy something. Now it's 160, yeah. Okay, so it's still working, all the asserts are passing everywhere. Okay, so we have backpacks with those 3 things in them. So that means we can iterate over them and draw something. Finally. For both part 1 and part 2. Okay, so we kind of want the same sort of layout. It's like backpacks. New and panel. Okay, so we begin a panel, we end the panel. Oh yeah, but within the begin panel we actually want another layout. And here we have some total height, right? Int total height, which we're gonna have to work out somehow. So right now we should have like a scroll bar, presumably, no? Is that because it's not high enough, or what? Laying out this row. Interesting. definitely want that. Is it because we didn't throw anything in there, or? Oh yeah, there it is. There is the scroll bar. Well, for each backpack solution backpacks, we have stuff in here like comp1 and comp2. So let's say mu draw text, so it's that call. Oh my god. Style font, so this would be backpack comp1 position. Well, yeah, we kind of do want a rect there, right? So mu rect comp rect is total bounds. Let's start here. The total bounds x, total bounds y, width. Well, we don't actually know how wide it should be. And height would be font height times 2, so that's not going to change. And position should be mu vec2 comprect x comprect y, and then comprect x plus equals the length of this times font width. So kind of like that. Well, actually, let's backpack index. Well, no, we don't need to add anything. If backpack index is greater than 10, great, let's just do the first 10. Does index come first? Like, what's the... Yeah. Yeah, that looks about right. Well, of course we want some padding. Yeah. And we also want a kind of a back, so this thing is comprect width is that. Cast. Yeah, so that's the same, that's fine. We want a rect here. Probably with border, yeah. Color. Well, looks about right. Because there's padding, right? And this should be plus padding divided by 2 to center it. Yeah, so there's our compartment. Of course, we have 2 of those things. Text, position. Text position y plus equals font height. Let's say. And now this is just compartment 2. Yeah, this seems to be working fine. Now the text color should, I mean, I think it's fine as is, more or less. More or less fine. It's more or less fine as is. Okay, now let's do wrapping. If comprect x plus comprect width is greater than total bounds x plus total bounds width. So if we're going out of bounds, then comprect x equals total, but reset it. Also, we have that assert in there when we're doing wrapping for the previous one. And I think we should just remove it. Like, if we can't fit the rect, then we can't fit the rect. Still gonna draw it. Oh yeah, y plus equals comprect height. Yep, that looks about right. Well, let's draw all of them and just see what that's like. It's like that. Yeah. Well, the only thing that's missing is highlighting the common element. Of course, highlighting the common element would mean we want to know where it is, which we're not really storing that information. And there's no easy way for us to even really store it, right? Because we're not storing positions. And there could be more than one. Like if the common element here is, well, actually no, I think it appears one. Like whatever the common element here is, somehow I want to highlight it. I mean, we could just draw it in a different color. That's like, visible. I guess we can do that simply by drawing each string character by character, and whenever we see a character that equals one of these, that equals the common one, just change out the color. Draw string. I mean, I guess it's gonna have to be a special string. So string is gonna have to just be that, and length is gonna be 1. New vec2 chpos is text pos. Chpos x plus equals font chwidth. Yeah, so text pos is here, then draw str, solution, no, backpack, comp 1, text pos. That, and then draw str, backpack, comp 1, comp 2, text pos. Something like this. I think this should look the same. It does. Right here, if ch equals backpack common, yeah, if it's one of these, then color should be changed. Color A plus equals 50 or something. New color is excess color. Well, A. Why A and R? Yeah, I mean, that does highlight it. And I mean, if you look at it, you can kind of see it. There's multiple M's here. Yeah. V, P, and N. Yeah, I mean, I think that's good enough. Like, we can see it. Yeah, we can't see the priority sum from here. I mean, this would be like if we had to stretch out each of these. Are there really not that many? There aren't that many backpacks apparently. How many backpacks are there? Soul backpacks, 300. Is that 300? That doesn't look like 300. What is it? 19, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, I mean, I don't know, 17 times 19. Yeah, that does. Do I really have to run it? Just no. I mean, that looks about right. I guess 300 isn't that much visually. could stretch out each of these based on that letter and its priority. No, we could not. I mean, we have the sun there, right? Yeah, I mean, we kind of already did that here. So just doing that again isn't very interesting. This is fine, probably for part 1. It's part 2. Part 2 isn't very different. All 3 L's will have B somewhere in the rucksack. Yeah, well, we can mark, like, we know what that is, right? So we can just mark. And against the sun. Yeah, so we could just go into the solution. And say, well, there's the badge. And that's us looking for a badge right here. And of course, it's only every 3rd backpack that's gonna have the badge index, and it's the same index for every set of 3. So do we just store a char array, which is like badges? Like, we don't even need the priority here. Not doing anything with it. Dynamic array char for the badge storage is dynamic array char scratch temp memory. Let's not forget that. Temp memory temp equals temp memory scratch. So there's our badge storage. So right here we would do badge storage push badge char, so we have to work that out somehow, and then badges equals badge storage copy to the arena. Yeah, so badge character. So I suppose that would be like int badge priority is something, which we just save here as priority, and then we do need to do this back transform. sure. Takes int priority and returns that. Get char from priority. Okay, well, let's see if that even works. It does. Okay, so now that we have these badges, actually we have to check something here. Let's put a couple of asserts like backpacks, length divided by 3 is badges, length, and also the opposite, badges, length times 3 is backpacks length. Does that pass? Yeah. Okay, well, given that we are here now, and we have these badges, which is a char array, it should be pretty easy to just get a char badge char is solution badges, and it's simply backpack index divided by 3. Just floor it. Else if char equals badge char color G or something plus 50. Okay, well, okay, so S, S, S. That looks about L, L, L. D, D, D. J, J, J. Yeah, see, this seems to be working. Do badges only appear in one compartment, or like in both, or? Getting any other item type. Only items type carried by all 3. Okay, well, nothing here says that it can be both shared and, so I guess this should just be that. S, 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 G, 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 V, V, V. I mean, yeah, this seems to be working just fine. That's honestly probably all we need for part 3. Okay, so we're gonna solve that. This is pretty much done. Okay, let's just do that. Yeah, this looks fine. Visualize is part 3. I mean day 3. Alright, well, that's it for today. See you later.